Hi everyone. Okay, I'm gonna take this one a bit differently because this is a really easy integral. You can guess its answer just by seeing the bounds without even looking what's inside. But um, so today we're gonna be looking at, instead of solving the integral, explaining how one would solve the integral to somebody who is maybe new to integrals. Okay, so the answer here is pretty clearly zero to anybody who knows what an integral is. We know that this is zero, and I've checked, of course, this is correct. So, how do we know this is zero? So, first off, anyone who knows what integrals are doesn't get it immediately. We know it's zero because it's from a to negative a of an odd function. That makes it zero. What does that mean? Well, an odd function, if you were to graph it on the Cartesian plane, if this is x, this is y, um, an odd function is any function that looks like this, where it's like, so this, if you take this part in the first quadrant, flip it over the y, flip it over the x, you get the other part. This is an odd function too, and so is this. Why does this matter? Let's look at what an integral is. An integral is equal to the area. So if we have a function that looks like this, a quadratic function, the integral from 0 to, let's call this a, is this area here. If we have this quadratic, it's from 0 to a. Since this is below the x-axis, this is going to be negative. So if we have an integral of something like this, sine, we have this, and this. This is going to be a positive area, this is going to be a negative area, this is going to be a positive area, this is going to be a negative area. So if we take it from something like here to here, or maybe here to here, we're going to get 0. So a general rule, if we look at any odd function, let's just look at y equals x. If we take an odd function and we have the bounds from negative a to a, so basically the same distance from 0, then the negative a to a, then the integral is going to be equal to 0. Because this is going to cancel out with this. Okay, cool. How do we know that this is odd? So first off, we know that sine to the 2025 in and of itself is odd. Why do we know this? Because first, we know the base sine is odd. We see sine, this is what sine looks like. This is a flipped over y flipped over x version of this. So if we were to take it from here to here, the area should be 0. To the 2025, that doesn't change anything. If it were to the 2026, that would, because then that'd take the absolute value. Wait, guys, I'll be right back. Okay, let's finish this. Okay, I was getting to why sine. Okay, we know sine is odd because you could see, oh, it flips, right? Okay, sine to the 2025 is odd. You take anything to an odd power, it stays being odd. Let's take, for example, if you take it to the third power, everything, or to the 2025th power. It doesn't matter how far away it is from 0, or it doesn't matter if it's positive or negative, anything is the same. If you have x to the x to an 2k plus 1, we know that's going to be equal to x to 2k plus 1, or 2k, do plus 1, yeah, plus 1. We have negative x to the 2k plus 1. We know that's going to be equal to negative x, negative x to the 2k plus 1. We can see the negative and positive stays the same, it's just the magnitude of these numbers, and that doesn't matter. All we care about is that if you have here x and here negative x, it's gonna stay like that. It's gonna stay. This could be 2x, but this would have to be negative 2x. That stays the same. We just see that the positive and negative changes. Okay, so we determine that sine is in fact odd. Sine to 2025 is in fact odd. We see the bounds here. This is from negative pi to pi. We know that's negative a to a, so that's fine. Now we look at cosine. Cosine to the 2026 is even. How do we know this? Let's first look at cosine. Cosine is an even function, we can see. It will look like this. It's even means it's the same flipped here and here. So, this has the same value as this has the same value as this. That's good. So even does not affect the oddness of this, because this, if you're multiplying this by this, it's just going to change the magnitude. It's not going to change. These are both going to have the correct signs. They have opposite signs. It's just going to change the magnitude since it's the same value here. We take it to a 2026, since we're taking an even function to any power, it stays even. Because the 2026 just changes the magnitude of these. Although this will become positive, that doesn't matter. We just need the signs and magnitudes of these to be in the correct, to be equal. The signs to be opposite, magnitudes to be equal. If it will be to 2026, it will look like something like this, I think. But this will just like go to 0, and then this will just go to 0, pretty much. So, it will be incredibly small, but it's fine because they will, since it's flipped over the x-axis, the positive and negative sides will just be the same flip. So they'll be multiplied by the same thing. So if we can show that since this is even, this entire thing is even, then this thing is odd, then this entire thing is odd. It's even does not affect the oddness. So therefore, because we have the integral from a to negative a, have an odd function, the area, or the integral, is 0. Now, how did I know this so quickly, and how did most probably people who do integrals know so quickly? First, we see pi to negative pi. It's the same bounds, and and I don't say almost always, but like a lot of the time when you see this, it's going to indicate that it's 0. Check this, you could just do what I did. You see that this is odd, this is even, this is odd. Cool. Okay, well thank you for watching, I will see you tomorrow. And, goodbye. I don't think this is day 365 yet, although we're getting pretty close. Bye.